Okay, so extrema are the tops. So we want to estimate extrema. I want you to notice that when we were dealing with quadratics, we were able to find the maximum height, like right here. We were able to find our maximum value, that top of the hill. Unfortunately, there's no good like equation for polynomials to find that, which is really easy with quadratics. However, the math is coming. It's just we're not ready to learn it right now. It'll be in later math classes. However, in this section, we're just gonna be estimating extrema. Extrema are the top of the hills and the bottom of the valleys, locating what those are, the values of those. So the best we can do today is we can like just graph it and then using our graphing calculator, and then we can estimate that, what they are using a graphing calculator until we get that later mathematics. So let's go through this word problem because it's a pretty good word problem and it's kind of difficult writing out this equation. So I want to go through it. I have it all here for you that I already wrote out, but let's read it and I'll explain it to you. An open-top box is to be constructed by cutting out squares from each corner of a 14 by 20 centimeter sheet of plastic, then folding up the sides. Find the size of the squares that should be cut out to maximize the volume enclosed by the box. So it sounds like they have this square, or not, sorry, not square, rectangle piece of plastic, and they're going to cut out a square from each of the corners, of the four corners. Okay? And they want us to find the size of the square that should be cut out to maximize the volume of the box. So when they're done cutting out the squares of the corners, then they're going to fold up. So see the red lines here, the little red dotted line, that's where they're going to fold up these sides. And it's going to look like this. It's going to look like a box without a top. So if I want to maximize volume, I must first write an equation for volume, which is good because we have an equation. Volume is equal to the length times width times height. So I define an expression for the length, expression for the width, and expression for the height. I let the amount that we're looking for, which is the amount that we need to cut out to create the squares, I let that be our x. So if I cut off x amount here, then it would, since this is a square, I would have to cut x off amount going up as well. So that makes this length, it's got to be the original 20 minus an x on one side minus another x on the other side. So it's 20 minus 2x. That will be the length. Then the width of the box, which is right here, that needs to be the original 14, same thing, minus an x on this side, x on that side. So 14 minus 2x is the length of this box. Then notice when we fold this up, the height is going to be that x itself. So we have an equation here, 20 minus 2x and times 14 minus 2x times x. It was important I put these in parentheses, right? Okay, so next I can multiply this out if I wanted to, but I'm just going to enter that straight into the calculator to get the graph of this. And I'm going to show you how to do this in a calculator so that it's easier for you. So here's my graphing calculator. This is a Calc 84. I'm using my calculator. It's very similar to a TI 84. So I'm just going to type in, I'm going to use the parentheses here, parentheses, and then the 20 minus, oh, I said divide, huh? Oops. Let's delete that. Minus 2, and for a variable, you put in the x, which is in the top left corner. In parentheses, I don't have to put times because it's just going to assume I'm multiplying when I put two things next to parentheses. My calculator is smart and it knows I mean times. Then just times x. So I entered that all in. Now I press graph. And this is why I teach you guys about where the x-intercepts are, where the y-intercept is, because those are going to be important parts of this graph. And as you can see, what's happening to me right now is I don't have the right window. In other words, I'm not looking in the right zoom, if you will, so that I can actually see the action of this graph, because we're looking for the maximum of the hill, because this graph is the graph of the volume. And I need to find the maximum volume. So we need a different window. So I click in window. This is why we teach you about the x-intercepts. This is why we're going to eventually teach you how to find the maximum. Because knowing this window is really, really important. And I happen to know the window right now. So the x min, I'm going to go ahead and keep that. I'll just put that to -1. My x max, let's go to 11. Because I know where my x-intercepts are, so I know that we're going to see the x-intercepts on that interval. The y min, let's go with -100. And the y max, let's go with 350. This is because I have knowledge of this graph. See, I wouldn't be able to do this unless I have knowledge of the graph. And this is why I teach you how to graph it and not just tell you to do it on the calculator. Anyways, here we go. This is our nice graph. So as you scroll around on the graph, look, the max actually is highlighted for me. So now we can read this. As notice how as you move, it's reading the x coordinate and y coordinate. It actually found the max for me. As I get close to the max, it knows what I would be interested in. So it says, hey, are you interested in the max? Because the max is this. So it has it written right there. X equals 2.7 and y equals 3.39. So the x coordinates here were the length of the box of the square that we were cutting off the edges, right? And the y is the volume. So what it's telling me is that I can cut off 2.7 centimeters, a square 2.7 by 2.7 on each corner, and when I do that and form that box, then I'm going to have a maximum volume of 3.39. So that's the best way. That's the best that we should do with our material here to maximize our volume. There you go. So that's the best we can do today, is we can just get close to this max and use technology to help us find this max. And later we're going to have, you'll learn more techniques to actually find that maximum. Okay, have a great day.